Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to everyone and fellow panelists. My name is Muhammad Haziq bin Abdul Aziz, and today my friends and I, we are from Group XO, and today we are going to present about our project, which is product design of a flower sieve. So I'm going to start with the organization chart of our group. So for this project, my friend Abdullah Amir will act as the general manager of the project. Nur Afiq will act as the project manager, while myself and Muhammad Shamin will act as the material and design engineer. So what is the objective of the project? The objective of the project is to create an innovation of a flower sieve that meets customers or respondent demands based on the survey that has been distributed to the respondents. So in the survey, there is a total of 17 questions and has been distributed to a total of 43 respondents. One of the questions that been asked in the survey is, what is the most common problem that being faced by the respondents? The majority of the respondents think that the conventional flower sieve requires too much energy to operate, while others face problems such as messy flower at the workstation and leftover flower in the flower sieve. Based on our survey and analysis, there's a few problems with the conventional flower sieve that we are trying to solve with our new product design. So the first one is sifting flower using the conventional flower sieve is a time and energy consuming process. Since conventional flower sieve is manually operated using hands, it requires so much more energy compared to our product, which is fully automated with motorized technology. So the next one is conventional flower sieve can only sieve small amount of flower at a time. So this could be a problem for customers that need to use a large amount of flowers in a cooking or baking session. So conventional sieve is not efficient enough for them since it takes too much time for them to sieve the flower. And the last one is a messy workstation. With our new design, we try to make sure that minimum mess is created during work. So next is I'm going to talk about the Gantt chart. So for the first 4 weeks of the project, we spend our time to discuss the theme of the project and to make research on the existing product and market analysis. Starting with 5, we have started to generate our design concept. From several design concepts, we have evaluate the most suitable and the most perfect product designed for us using flowchart. And we also have carried out material and cost analysis at week 7 and week 8. Starting week 9, we have moved on to detailed drawing and specific part design. We take almost 3 weeks for the detailed drawing and individual part design. Later on, we also have carried out structural analysis and also, of course, the digital prototype of our product. Along the way, we have made a small detail improvement of our project. And finally, the final presentation today. So after this, my friends will explain more in depth about our product details. So that's all from me. Thank you.
warahmatullahi wabarakatuh. My name is Muhammad Syamil Shazwan and I will present about the conceptual design of our IPD project. The first is our data analysis. So based on the data collected from the survey, there are some of the common problems and disadvantages that users have faced when using the current market sieve that exists. So one of the few problem and disadvantage that our group has found is that the first is the conventional sieve requires extra energy to operate, and it is hard to keep the workstation neat during the sieving when the correspondent use the siever. And then 4 out of 42 correspondent do not face any problem with the current siever. And the survey also shows that the more than half of the correspondent, about 57.5%, prefer an automated sieve machine compared to a conventional sieve. More than 75% of the correspondent prefer a portable sieve rather than a station sieve, the sieve that is much more easier to be placed anywhere. The next is almost 60% of the correspondent prefer medium-sized sieve with a medium maximum capacity of the floor. And the last is the most problem, about 34% from our survey face that the correspondent during sieving is that they require a lot of energy to sieve. So they are much more preferred to an automated sieve. Next, our gap analysis. So our design state product is that a floor shifter with a vibration, and our gap is that the flow system in the node shifter, how the product will flow with our new shifter when at where the flower will enter and exit from our shifter. Next is how to add vibrator in the node shifter. Either we place outside, inside, or beside our shifter. And last, in our gap is our costing. We don't want our product to become too expensive to our customers. And our solution is that we produce 3 ideas and compare to the benchmark product. So we will design 3 design sketches and we will compare to a benchmark product which is the best for our shifter. And the next is our budget analysis. So we will analyze our budget so that we will not overprice our product and make it more expensive and will be less liked by the customer. And lastly, we solve how to withstand high load of flower. So we will have a calculation shown about the load of flower that can be placed on our new shifter design.
For machine element design, we want to calculate how much weight of flour that can fit in our flour sieve machine. Firstly, we need to calculate the volume of our flour loaf which contain the flour. And from the calculation, we get the total of 8.344 times 10 to power of negative 3 meter cube. For the density of flour, we know that it is 593 kg per meter cube. So, to calculate mass, we need to times the density of the flour and the volume of the flour loaf, and we get the total of 4.93 kg of flour. So we assume that around 5 kg that can fit in our machine.
Next, I want to present about the conceptual design of our IPD project. So here is the 3 design sketches from our group for our siever. Okay, for the first design, here I want to explain about the first design. For the first design concept, it shows when the flow goes on top of the siever, the floor will go through a double shiver to make the floor produce a more finer result. Then it will goes down to a metal sheet cone shape with an angular end for easier to collect the final product of the floor. The design comes with a vibrating motor on the bottom of the support with the support of a spring leg to absorb the vibration at the base. So the function of the vibration motor is to move the floor, to shift the floor when it goes through the shivers. Next is the second design of our sketches. So the second design is mainly for a large amount of product from 10 kg to 20 kg of floor to be sheathed. The design is much larger and can only be placed at one spot only. The design have a spring that is connected to the sheath and the stand of the sheath. The sheathing is operated using a motor that connected to the spring and then vibrate to move the shiver. Even though the design looks simple, but it is suitable to shift a large amount of floor one at a time. And last is the design tree. So the concept design for design tree shows that the design comes with a more modernized and aesthetic look. It also comes with a quite medium size, about 400 mm of height and 330 mm of wide. The sheath comes with three separated bodies. For the first is the sheathing part, the second is for the outer body, and the last is the finished floor compartment. For the sheathing part, the sheathing part designed in a cone shape with a cylindrical end shape. This is to avoid the floor being spilled out during the sheathing process. The shiver is equipped with a blade that spins during the sheathing to break down the excess flow on the shiver. The blade is powered by a 12-volt DC motor connected by a belting to spin the blade. The AC vibration motor is placed on the sheathing part to produce vibration during sheathing. The second part is the outer body. So the outer body is made up of sheet metal, and the function is to cover the sheathing part from producing floor dust during sheathing. And the leg support on the bottom part of the outer body is made out of a suction cup leg. This is to avoid the shiver move during the sheathing operation. The outer body and the sheathing part is connected with a bolt and a spring. And lastly, the compartment, the floor compartment. So the compartment can be detached from the main body. This is to make it for the consumer to be easier to access the finished product. Next, I want to present about the final conceptual design that our group choose. So based on the perf chart, as you can see, the highest net score and the first rank for our, based on our 3 design sketches, design number 3 has been number 1 for our group design. So with the result, our group has decided to choose design number 3 for our final conceptual design project.
Hi, my name is Abdullah and I would like to Alright, as we can see that there are a bunch of bill of material that we combine to make our floor sieve product, and it consists of outer cover as a main part to cover the internal machine. Okay, second is we also have the floor loft as a place to put the floor before it will be sieved. Okay, next is we also have bolt and nut, which is function to tie the main body and the floor loft. Okay, next is we also have spring, which function to make a little vibration and make sure the efficiency for the amount of floor that be sieved is increased. Moreover, we also have silver, which is an important part of the product, and also the plate for and after that, the floor will be transferred to the brass container. Okay, lastly, we also have a suction cup leg which help to make sure our product is stationary state and absorb the unwanted vibration. Okay, next, as we can see above, that is the exploded view for each pipe for our sieving machine, which totally consists of 9 pipes, and each pipe play their own role during the machine is running. Okay, next is there are the animated for the exploded view for our design, as we can see above. Okay, let me play. Okay, next is product specification. Okay, I'm sure that you are wondering what our product specification, right? Okay, let me explain. First, our product machine can be sieve the floor from 1 kilo to maximum 5 kilo in one time. Alright, next is our sieving product estimatedly weight is 7 kilo and it is fully automated. Okay, the duration of the process estimatedly can process 3 kilo of floor below than 5 minutes. Other than that, this machine also can raising a blade as an accelerator to help sieving the floor. The product also use stainless steel material as the product material to prevent rusty, as we know that we are dealing with food preparation and manufacture. Okay, lastly, we also use the rubber suction cup at the base of the machine to make sure this machine is in stationary position and also absorb the unwanted vibration occur during sieving process. Alright.
See the motion analysis, our critical part is the siever. So the total weight that we use, total load of we use is 49.05 Newton, which is the load of the flour, which is in kg is 5 kilogram. Okay, and the material we use is stainless steel. As we can see that it is blue color appear in the motions, which means that it is still can support the weight of flour and still not break. So if the red color appear, that means the siever will break. So in conclusion, that our design and our material that we use is suitable in this project. Okay, this is the result summary from our motion analysis for our critical part. As we can see, the maximum safety factor is 15 and the stress analysis is 20.54 megapascal, and as we can see, the total displacement is where our critical part is bent, which is 0.05053 millimeter, and it is very small amount of bend. So that means that our critical part still can support the maximum weight of the flour. This is rendering. To do this process, we use Fusion 360 to make the rendering. So the purpose of rendering is to make the product or the design more realistic. In the animation video, we want to show you guys how our machines works. As we can see, the blade is turned around to make sure all the flour will go through the sieve, and the blue part, which is the brass container, which contain the flour after the flour is sieved. So as we can see, we need to pull it out after the process of flour sieve. For the overall conclusion of this project, the flour sieve machines project was to satisfy our customer needs. From the survey earlier we had made, many customers want an automatic machines bigger in size and which can sieve more flour in a time, easy to use and more efficiency. For our design, we have met the requirement of the customer needs, so we built the design with the survey that we had been done. So for this project, we had designed the best design to satisfy the customer. So thank you.